Today we're going to look at something called function notation. Let's start with the warm-up. Determine whether the following are functions or not. So if we look at the first one right here, it's this wavy line, and we want to see does it pass the vertical line test. And the vertical line test says for every x value, so for every vertical line, there's only one y value. And you can see that anywhere I draw a vertical line on here, there's only one answer. So again, for every vertical line, is there only one answer? Yes, so the first one is a function. Now the second one right here, ignore the line right here. Let's just look at the dots, all right? Again, if you draw vertical lines, does every x value only have one y value? And if you take a look, most lines that I draw only have one, but here when x is 2, there's two answers here. And so this is not a function because for when x is 2, you have two answers. So 2 is not a function. Let's take a look at number 3. Number 3 would not pass the vertical line test because in several spots, like at -4 or -6 or 2 or any of these values right here, there are two answers. And again, a function, for every x value, there's only one answer. So again, this would not be a function. And our last one, our V-shaped graph right here, this is a function. For every x value, you can see there's only one y value. So last one, yes. All right, let's look at a function in this mapping right here. Again, you're looking for every x value, and we'll say x is the first ellipse and y is the second. For every x value, is there only one answer? And for the first one, no. -5 has two answers, 4 only has one. Number 6 here is a function because every x value, every input, only has one output. Now it's true that two of them have the same output, but that's fine. As long as every input has one output, it's a function. Okay, so example 1 is the following a function. Yes, it is. Passes the vertical line test. Determine the equation of the graph. So we have it's linear, so y equals, we need a y-intercept, it's 5. Our slope is negative, goes down 2 over 1, so minus 2x. So there's this thing called function notation, which just says f of x is the same as y. So we can say f of x equals 5 minus 2x. And the reason why we use function notation, two things. Number one, it tells you that it is a function. And number two, there's a shortcut, a shorthand way of saying substitute something in. So when I say find f of 2, what that means is plug in a 2 everywhere you see an x. So f of 2 means when you plug in a 2, we'll get an answer. So f of 2 equals 5 minus 2 times 2. 2 times 2 is 4. 5 minus 4 is 1. So we say f of 2 is 1. And we can see that on the graph. When x is 2, when you plug in a 2, you get 1 for an answer. So function notation, this is pronounced f of x, and it's the same as y equals. It's telling you it's a function, and if I put a number in for x, it tells you what to plug in. So when we plug in a 2, we get 1 for an answer. Let's do a few more of these. So let's say we have this function h of x. h of x equals 2x minus 3, which means the y-intercept's -3 and the slope is 2. Find h of 7. It just means plug in a 7 everywhere we see the x. So we have 2 times 7 minus 3, and I'll write my work over here. H of 7 equals 14 minus 3. So our final answer, h of 7 is 11. It means when you plug in a 7 for x, the output is 11. Let's try the next one, h of 0. So h of 0 means 2 times, h of 0.5, not h of 0. h of 0.5 means 2 times 0.5 minus 3. So again, let's write our h of 0.5 equals, 0.5 means half, so half of 2 is 1, so 1 minus 3. So our final answer, h of 0.5 equals -2. When we plugged in a 0.5, we got -2 for an answer. So that's how you use substitution with function notation. It tells you what to plug in. You plug in and solve and write your answer. But sometimes I give you the output or the answer, and then you have to solve for x. So these problems will say find x. If the answer, g of x, is 28, so here we plug a 28 in for g of x, 28 equals 3x minus 5, and now we're going to find x. So now it's just algebra. You add 5 to each side, we get 33 equals 3x. Divide by 3. So here we want x. X is 11. Let's try the next one. Find x if the answer, the output, is negative 26. So we have negative 26 equals 3x minus 5. We'll add 5 to each side. We get negative 21 equals 3x. Divide by 3. So x equals negative 7. So when you're given the output, use algebra and solve. When you're given the input, you plug in, substitute, and you find your answer. Okay, so today you're going to practice plugging in the right spot, also reviewing if something's a function or not.